Sometime around the year 2036, a NASA engineer in Pasadena is going to sit at her console and watch a number drop below a threshold. The signal from Voyager 2 will become too weak for the Deep Space Network to pull out of the background noise. She'll probably check twice, maybe ask the next shift to look again the following day, and eventually she will write a short internal memo that says the spacecraft has fallen out of contact. It won't be a dramatic moment. There won't be sirens. The signal will just become indistinguishable from cosmic static. But when that happens, something quiet will end. For the first time in over 60 years, no human-made object beyond the solar system will be talking to us. Pioneer 11 went silent in 1995, Pioneer 10 in 2003, Voyager 1 will fade sometime around 2030, Voyager 2 a few years after that. New Horizons, the youngest of the fleet, will run out of usable power sometime between 2030 and the late 2040s. 5 spacecraft, 5 different engineers on 5 different days, each one closing a logbook on a machine that kept going long after anyone expected it to. What happens to those spacecraft after the last engineer closes the last log is what this video is about. Not for years, not for decades, for billions of years. This is the 4th episode of Outbound. Each one follows a single spacecraft as it disappears into deep space. We've already told the story of Voyager 1 on its own. We've already told the story of Pioneer 10 on its own. Tonight is different. Tonight we're following all 5 at once because they are now part of the same long story. A small fleet of human-made objects separated from each other by tens of billions of kilometers, all heading in different directions, all of them already older than the children who were born the year they launched. Let's start with the first one to go. Pioneer 11 launched on April 5, 1973. It was the first spacecraft to fly past Saturn, the first to cross the orbit of Neptune, and the second human-made object to begin the long drift out of the solar system. By the mid-1990s, its plutonium battery was almost gone. The radioisotope thermoelectric generator that had kept it warm and powered for 22 years was producing less and less electricity each year, and there came a point where the spacecraft could no longer run its scientific instruments and talk to Earth at the same time. NASA had to choose. On September 30th, 1995, the Deep Space Network's antennas at NASA Ames Research Center received the final scheduled transmission from Pioneer 11. The spacecraft was 44.1 astronomical units from Earth at the time, more than 44 times the distance from the Sun to our planet. The signal had been traveling for over 6 hours at the speed of light before it reached us. A few weeks later, on November 24, 1995, the engineers got one last unexpected window. Pioneer 11 sent back a few minutes of basic engineering data, status readings, temperature, voltages, no science. That was the last time anyone on Earth ever heard from it. The reason was almost embarrassingly mundane. Earth's orbit around the Sun had carried our planet out of the alignment where Pioneer 11's fixed antenna could point at us. The spacecraft was not broken, it just couldn't aim anymore, and we couldn't move Earth to compensate. It is still out there, heading toward the constellation Aquila, the Eagle. In about 4 million years, it will pass within a few light years of the star Lambda Aquilae. That isn't a flyby in any meaningful sense. It is a distant, indifferent passage by something that no longer knows the star is there. The plaque is still attached to its frame. The drawing of the man, the woman, the hydrogen atom, the position of our sun in the galaxy, still aimed at nothing in particular. Pioneer 10 was the older sister, launched in March of 1972, a year before Pioneer 11. It was the first human-made object to cross the asteroid belt, the first to perform a close flyby of Jupiter, and the first to leave the orbits of all the known planets. Its official science mission ended on March 31, 1997. But Pioneer 10 didn't actually stop talking. It kept sending a faint, slow signal back, and the Deep Space Network continued to listen to it occasionally, partly out of nostalgia and partly as a testbed for future deep space communication. On January 23, 2003, the antennas heard a final faint signal from 12.23 billion kilometers away. That's about 7.6 billion miles, well past Pluto, further than any object we had ever spoken to. And then nothing. The spacecraft wasn't broken, the transmitter hadn't failed. The plutonium had simply decayed past the point where it could push enough power through the antenna for us to pick out the signal from background noise. Pioneer 10 is now coasting in the general direction of the red star Aldebaran, the Eye of Taurus, about 68 light-years away. It will arrive in roughly 2 million years. There is one detail about the Pioneers that astronomers still find a little uncomfortable. For decades, while we were still tracking them, both spacecraft were slowing down, just slightly, just enough to fall behind where the calculations said they should be. The effect was consistent in both probes, and it didn't quite match anything obvious. For a while, it suggested that maybe gravity worked a little differently at large distances. Physicists found that exciting and a little terrifying. The current best explanation is more boring. Heat from the spacecraft itself, leaking unevenly into space, pushing back against its own motion, a tiny thrust nobody had quite accounted for. But the deeper truth here is humbling. We are still, in 2026, working on small mysteries left behind by machines we haven't heard from in over 20 years. Even in silence, Pioneer 10 and 11 are still teaching us things. Then there are the Voyagers. Voyager 1 was launched on September 5, 1977. Voyager 2 was launched 2 weeks earlier, on August 20th. You know these names. They are the most famous spacecraft we've ever built. They visited Jupiter, Saturn, Uranus, Neptune. They sent back the first close-up pictures of the giant planets and their moons. They carried the golden records, the gold-plated copper discs containing greetings in 55 languages, music from around the world, the sound of a heartbeat, the cry of a baby. They were designed to last 5 years. They have been working for 48. Voyager 1 crossed the heliopause, the boundary where the sun's solar wind gives way to interstellar space, in August 2012. Voyager 2 followed in November 2018. They remain the only 2 spacecraft to ever leave the bubble of influence of our star. But they are dying. The plutonium that powers them has been decaying steadily for almost 5 decades. The engineers at the Jet Propulsion Laboratory have been turning off instruments one by one to keep the spacecraft alive a little longer. Heaters first, because the spacecraft are warm enough from the residual heat of the RTG itself. Then cameras, because there is nothing left to photograph. Then individual science instruments by priority. NASA's current best estimate is that the 2 Voyagers can remain within range of the Deep Space Network until about 2036. After that, the signal will simply not be strong enough to detect, no matter how big the antenna on the ground. The engineers know the moment is coming. They aren't preparing for a dramatic event. They are preparing for a number that drops on a screen in a quiet room. When Voyager 1 falls below detectability, the spacecraft itself doesn't change. It still moves at 17 kilometers per second in the same direction it has been moving since 1977. In about 40,000 years, it will pass within 1.6 light-years of a small red dwarf called Gliese 2445 in the constellation Camelopardalis. That distance is closer than any star is to our Sun today. Voyager 2 is on a slightly different path. In roughly the same time frame, it will pass within a few light-years of Proxima Centauri, the closest star to our solar system. Neither will stop. Neither can stop. Nothing in interstellar space can decelerate a 2-ton metal object moving in a near-perfect vacuum. They will simply keep going. The 5th member of the fleet is the youngest and the strangest. New Horizons launched on January 19, 2006, on top of an Atlas V rocket that accelerated it to the highest velocity any human-made object had ever reached relative to Earth. It was built to fly past Pluto and find out for the first time what the most famous dwarf planet in the solar system actually looks like. It made that flyby on July 14, 2015. The images it returned showed a small, frozen world with a heart-shaped plain of nitrogen ice, mountains of water ice taller than the Rockies, an atmosphere of methane drifting up into space. 3.5 years later, on New Year's Day 2019, it did it again. It flew past a tiny Kuiper Belt object called Arakoth, two lobes of rock and ice that have been sitting in their original form since the birth of the solar system, the most distant object humanity has ever explored up close. And then New Horizons just kept going. Like its predecessors, it is powered by a radioisotope thermoelectric generator, 11 kilograms of plutonium-238 dioxide, the same kind of fuel that powered the Pioneers and the Voyagers, the same kind that has been failing slowly since the day of launch. Its RTG output drops by about 3.5 watts every year, sometime between 2030 and the late 2040s, depending on how the team rations the remaining power. New Horizons will lose the ability to do science. After that, communication with Earth will degrade until it stops. If the spacecraft survives long enough, it is expected to cross the heliopause around 2047 and join the Voyagers in true interstellar space. But unlike the Voyagers, New Horizons does not carry a golden record. It does not have a plaque like the Pioneers. It carries something quieter. A small amount of the ashes of Clyde Tombaugh, the American astronomer who discovered Pluto in 1930. He died in 1997, 9 years before the spacecraft launched. He never lived to see the world he discovered up close, so the team sent a little of him along. There is also a CD with the names of 434,000 people who signed up to send their names to Pluto in the years before launch. A Florida state quarter, a piece of Spaceship One, a couple of flags. That's the manifest, more or less. When New Horizons goes silent, sometime in the next 20 years, Clyde Tombaugh's ashes will keep going, past the heliopause, out into the dark between the stars, carrying a man who looked up at Pluto in 1930 further from Earth than any human remains have ever traveled. I find that more affecting than I expected to. So now we have the fleet, 5 spacecraft, all either silent or going silent, all moving outward. And here is where the timescales start to break the human mind. The Voyagers, the Pioneers, New Horizons, they aren't almost in interstellar space. They are in interstellar space, or they will be very soon, and there is no destination ahead of them. There is no arrival point. There is just an indefinite billion-year drift through the dark. How long can a golden record actually survive? The Voyager records were designed with this question in mind. They are made of gold-plated copper, sealed inside aluminum covers, coated with a thin layer of uranium-238 that doubles as a kind of cosmic clock for whoever might eventually find them. The radioactive decay of the uranium gives a reader a way to estimate how much time has passed since the record was made. The biggest threat to those disks isn't radiation, it isn't cold, it isn't even time in the chemical sense, because gold doesn't really react with much. The biggest threat is dust. Interstellar space is mostly empty, but mostly isn't completely. Every so often, the spacecraft collides with a single microscopic dust grain. Each collision erodes a tiny piece of its surface. Over hundreds of millions of years, those collisions add up. The Cornell physicists who designed the golden record estimated, conservatively, that the disks could remain physically readable for about 500 million years. Some later estimates push that number to over 1 billion. Either way, the crucial point is this. The disks will still be readable after the Sun has expanded into a red giant and consumed the Earth. They will still be readable after the planet that made them no longer exists in any recognizable form. They will outlive their planet. The Sun has about another 5 billion years before it begins to die. In roughly 1 billion years, it will become hot enough to boil away Earth's oceans. In about 5 billion years, it will swell into a red giant large enough to engulf Mercury and Venus, and possibly Earth itself. By that time, the Voyagers and the Pioneers and New Horizons will have moved roughly 20,000 light-years through the galaxy. They'll be far from whatever is left of our solar system. And the Milky Way itself will be in the middle of merging with the Andromeda Galaxy, a long, slow collision that will rearrange the stars over hundreds of millions of years. Astronomers sometimes call the result Milkdromeda. Our descendants, if there are any, will live under a completely different night sky. The probes will still be there, their plaques and records intact, drifting through a galaxy that no longer looks like the one they were launched from. After 10 billion years, the merged galaxy will have settled. Stars will have died and been born. Most of the constellations Sagan and his team imagined the records pointing back to will have changed beyond recognition, and the spacecraft will still be there. They will pass close to other stars now and then. The probability that any of them gets captured by another star's gravity is extraordinarily small. The probability that any of them is found by another intelligent civilization is, by every honest calculation, near zero. But near zero isn't zero. And that is the point Carl Sagan understood when he insisted that the Voyagers carry the golden record despite the slim odds. He wasn't really sending a message to aliens, he was sending a message to us, to Earth, to everyone who would ever know that those spacecraft existed. The message was that we cared enough to try, that at one specific moment in our history, a species that had just learned how to leave its planet decided to put music and laughter and the cry of a baby on a gold-plated record and send it into the dark on the off chance that someone, somewhere, in a billion years might find it. That isn't a scientific gesture. It's something else. It's a small, fragile civilization making a statement of intent to a universe that owes us absolutely nothing. Sometime in the 2030s, the last engineer at JPL is going to receive the last data packet from the last working interstellar spacecraft. It won't be a dramatic event. The numbers will just stop coming in. The console will go quiet. The mission manager will write a final memo. There will probably be a small ceremony, maybe a press release, a line in a NASA newsletter. And then, for the first time since 1972, humanity will not be in active communication with any of its own creations beyond the solar system. The fleet will keep moving. The plaques will keep facing outward. The golden records will keep their thin-coated surfaces intact for hundreds of millions of years. Earth will spin on. Generations will pass. The names of the engineers who built those spacecraft will be forgotten by everyone except their families. The companies that contracted the work will close. The countries that funded the missions will change shape, change governments, change languages. And still, the spacecraft will be out there, carrying drawings of humans, carrying recordings of human voices, carrying the position of a small yellow star in a corner of an arm of a spiral galaxy where briefly life had figured out how to leave its planet. If you live long enough, you'll be alive when the last one goes silent. You may even remember the date. It won't feel like much at the time, a brief news story, a moment of quiet from the people who care about such things. But on the largest scale we have ever managed to think on, it will mark the end of something, the closing of a small window between us and our own machines, a silence we built on purpose, slowly, by sending things out faster than we knew how to keep talking to them. The spacecraft aren't really the message. We are. We have already left. If this episode resonated, the previous chapters of Outbound are on this channel. Voyager 1, Pioneer 10, and the engineer who killed Cassini. Each one is a different machine leaving us forever. The next episode is coming. Until then, keep listening to the silence.